afternoon, everyone. Today we have with us Professor Manoj Kumarji from the Delhi Technological University. Sir has an experience of more than 30 years in his professional journey, whereas Sir started his journey in 1992 with Banasthali Vidyapeeth, Rajasthan. Afterwards, Sir has served various institutions. The area of expertise that Sir holds is data structures, information security and cryptography, NLP and machine learning. We welcome you, sir, to the LPU, and with your permission, we start the Viva of Mr. Amit Sundas.
Shall we proceed? Good afternoon, everyone. My name is Amit Sundas. And today I am presenting my thesis report in front of you. My research topic is a novel machine learning based real-time vital signs monitoring system. I am pursuing my research under the supervision of Dr. Gurpreet Singh Sahi and Dr. Sumit Barodra. Dr. Gurpreet Singh Sahi is currently Associate Professor and Head of Department in Training and Placement Cell, CSC, whereas Dr. Sumit Barodra is on sabbatical leave from Benin University and is currently pursuing postdoc and research at National University at Singapore. Coming to the outlines, I'll start with abstract, introduction, literature review, research gap, novel problem statement, objectives, results, comparisons and discussion, conclusion, future works, and lastly end up with references. Moving ahead, abstract. So, with the problem as chronic and life-related diseases are increasing, affecting people's well-being and economic worldwide. To address this, we come up with smart patients and recommendation system, which we'll call it SPMR system, which uses deep learning and cloud-based services to monitor and predict patient health in real time. Key features of our system, that is, it uses categorical cross-anatomy, which is for optimizing and accurate health predictions. Secondly, the system also tracks various vital signs, predicts health outcomes, and quickly responds to various emergencies. Systems also basically watches vital signs, forecast health conditions, and provide quick emergency response. The system also uses health card to tackle safety issue in terms of smart health card systems. If I talk about results, here accuracy boost up to 36% in terms of F1 score. Also, accuracy boost in terms of prediction accuracy, it's up to 8 to 18%. Introduction. As mentioned, chronic diseases like health diseases, kidney diseases, diabetics are responsible among 71% of global deaths, which basically increasing a healthcare challenges in worldwide. With that, as populations are also growing and increasing, the healthcare costs are also increasing. And with that, the demand for effective smart healthcare systems are more in the market. With all, the new technology like IoT, machine learning and cloud services make it possible to monitor patients' health in real time, which is a smart and more effective way as compared to traditional remote patient monitoring system, which is basically currently lack in context awareness and data pre-processing or processing with respect to limited critical cares. With that, smart SPMR framework uses deep learning algorithms monitoring vital signs, symptoms and activities in real time, provides context awareness, adaptivity health solutions, ensuring timely predictions and intelligent decisions. Term of the table 1, it's referred reviews of healthcare framework for monitoring patients. So, here basically I have taken paper in between 2014 to 2022 where I have divided this as an title of paper, sample collected, quantity of occurrence, modeling used like ML, problem in the missing data which is currently occurred, characteristics of various top models, and lastly comparison with the existing models. With all this literature review, we have identified these areas where we can improve, where we can work. So first is integration challenge, second is improvement predictions monitoring model, last data handling, comparative model evolutions and benchmarking limitations. In this integration challenge, the challenge with respect to limited research on framework which combine personal medical rule, real-time vital signs and active context monitoring with respect to any critical symptoms for remotely. Second, improve prediction monitoring model. Here, inefficient models make it hard to monitor chronic diseases in terms of context awareness and accurate method to classify personal health with respect to the other. Also, large data handling, lack of robust methods are being there with in terms of unstructured and imbalanced healthcare data set. Competitive model evolution, insufficient studies as compared to local and cloud. Lastly, benchmarking limitations. Few models rigorously tested benchmarking against standard system using comprehensive, which means full data sets and matrices. Problem statement. So, with respect to all the research gaps, the research focus on enhancing current healthcare monitoring examination with real and the research focus on enhancing current healthcare monitoring by examining current machine learning and proposing a new solution which basically help to evaluate clear and perform good in the matrices. Whereas we aim to overcome integration challenge for developing both framework that combine personal medical data with respect to vital signs and activities which will boost our healthcare management. Additionally, our research design a framework for fast and accurate healthcare assessment for chronic diseases. Lastly, finally, we plan to evaluate various kinds of health classification model on both local and cloud platform to better understand their strength and weaknesses. To achieve all this, in this research we have identified following objectives. The objective 1, to analyze existing machine learning based vital signs monitoring system. Second, to propose a novel vital signs, to propose a real-time vital signs monitoring system using machine learning. Third, to evaluate and performance of the proposed system using various performance matrices. States of research activity. So it is divided mainly in 3 portions. First is objective 1, second objective 2, third is objective 3. So initial level will be defining or discovering the problem Then basically we'll questionize the research based on defining research objectives. In that basically we survey, various kinds of healthcare monitoring systems which are existing in the area. We'll define the requirements for novel system, then design proposed framework, then we'll basically move forward to the DL algorithm for both LPL and CPL, local and cloud platform. Then data collection and aggregations will be there. Then the proposed algorithms for CCE will be optimized and carried out, and then several other steps need to be taken care in terms of providing accuracies and precise, and lastly we'll gather all the information and write up the thesis. Moving ahead, for objective 1, we first identify various data sets. We search in various data sets in terms of the requirement like ASEM, IEEE, Scopus, Sign Direct, Willis, Springers, where we find various kinds of research. Here we basically observe there are 70 publications paper in terms of machine learning and vital signs monitoring system are present in the data sets. We refine the paper based on 2 criteria, applying inclusive, exclusive. Basically we divided paper which is needed for us. Then basically we selected only 28 paper where these vital sign monitoring systems have been present. Related work in terms of table 2, monitoring patients with chronic diseases. This related work had been identified. Title of paper where when it's published, issues with respect to address, architectures, what they follow, reliability, features, what they follow, tools and ensuring various reliability in terms of environment they used, functionality predictions like classifications, monitoring or analyzing what they have done. Similarly, cost, complexity, parameters and data size they have used. And lastly, recommendation, experiment domain, what they choose, and effective result, what accuracy they achieve with respect to all this. So, based on all this, we have identified dependent and independent parameter for vital signs. The list are below. For dependent, we've selected heart rate, SpO2, peripheral oxygen saturation, diastolic blood pressure, which is DPB, respiratory rate, and lastly systolic blood pressures. With that, other relative factors are also included like patient age, patient gender, patient's medical history, patient's physical conditions. With that, the independent parameters that are also been included like high activity, slow activity of the patients, ambient conditions like room temperature or atmosphere where they lived. Similarly, symptoms, are they having the symptoms earlier or recently it been occurred? Likewise, medications, are they under medications or not? So these are the dependent and independent parameters which was taken care. Based on objective 1, we have published this many papers. Moving ahead to methodology of objective 2. Here proposed methodologies for achievements of objective 2. Here we basically integrate our system design, then we start prediction and classifying algorithms are being proposed and used, then the data modeling in terms of handling unstructured larger amount of data and also imbalanced data are being taken care. Lastly, performance assessment where we evaluate and compare this research with existing research to create a benchmark. Proposed framework, it will look like this in figure 2. The proposed SPMR architecture and key components are being listed. So here basically we have 4 layer, AAL layer, which is we call it embedded assistance livings, where basically the sensor data is being collected from various patients or used to monitor the patients. Second layer, LIP, which is local intelligence if we need to only send the SMS, if we need only need to SMS doctor or psychiatrist to review the attendant, or call for the emergency services like ambulance, oxygens or psychiatry. Moving ahead, algorithm to propose cross entropy, categorical cross entropy. So here basically the input will be predictive probability, which we calculated using softmax, and then predictive probability list. It will contain various probability outcome by the other models. Then the resulting of cross entropy, which will be an initial empty list, which will at last calculate and give us the actual result in terms of cross entropy value. Here the steps will be initializing, then calculate cross entropy, calculate cross entropy between your actual probability and the predicted probability. It's basically append all these predictive and actual probability, then provide us the actual class which has been required for the accuracy and provide them. Then calculate the mean cross entropy. Then secondly, it adjusts the CE. If needed, it go back. It will back propagations. It will use back propagations, and then again weighted the layers, weighted in the dense layer, and then again the accuracy has been computed until we'll achieve the more higher accuracy. This work will be going on in term of that. Then lastly, the output will be adjacent cross entropy with the list of R, where basically the outputs of, you can say, the actual class which is been deriving the factor has been taken care. So based on all this objective 2, these are the research paper have been published. Moving ahead with objective 3, here methodology will be divided in two parts. First is performance analysis of SPMR. Second is basically security framework in terms of health card. Here in first methodology, several simulations were conducted where various different optimization parameters are taken care to analyze the parameter of proposed model in SPMR. With CCE based model in layer 2, it classify and predict the prediction conditions and send the alert to doctor or any caretakers. Similarly, cloud based models layer 4 utilize DL and responsible for some tasks as in which was not done by the LLP or which was not handled by the local predictive models. Here in security framework, we introduce a health card, which is a machine learning based framework designed to detect threats in smart healthcare systems. Here, threat is basically in this research we are not taking any active. We are not researching any passive attacks in terms of any adversive or you can say leakage or packets are being not considered in the research. And also we have assumed the data which has been collected from SRN are secure or are not compromised with others. So mainly here we have three types of attacks that we discussed. One is bogus data ingestion, second is DOS attack, third is compromised medical equipment. Bogus data injection, as if any persons basically provide or put wrong information into the machine, which may slow down our system. Similarly, DOS attack, here basically DOS attacks in terms of if the person is having access of the machines or system of the system, they can change some settings which can again lead to the disturbance of the system. And lastly, compromise medical equipment. Here any third party software can be installed into the system, which again slow down our system or force our system to go on sleep modes. With one, here basically I'll explain with the help of tables. So here basically we compromise the studies with recent we comprise various studies with respect to recent studies. So all the studies in terms of vital signs monitoring system have been taken care, and the proposed framework is being compared here, where basically our DL and noble CE patients sites accuracy is 93%, F1 score is around 91 to 97% in terms of multiple run, and then proposed DL over cloud, which is again 99.86%, and in F1 score in terms of emergency, when the patient is critical, it's provide 90 to 97, 96 to 97% of accuracies. So with that, all the confusion metrics of CPM A and B. A is basically all the confusion metric, where confusion metric of hypothesis patients P1, P2 and P3 have been considered here. Similarly, performance metric, here we evaluate using F1 emergency, F1 average, and then F1 average is basically taken with respect to F1 score. We have run the F1 score multiple times to get the F1 emergency. In terms of F1 emergency, it's basically signified the obtained use of value, which is again in the emergency classes or the data only, it's being identified. Then prediction accuracy. In terms of accuracy, it is basically harmonized to your harmonized average of true results and true classes. Then F score has been taken care, which is again harmonized mean or precise and recall, which precise is predictive predictions and recall is the real predictions. Comparisons of various prediction accuracy with the recent results with our proposed DL, both local and cloud. In terms of F square average, again comparisons have been done with P1, P2, P3 patients over 1 year. Then F score emergency. F1 emergency works over 1 year. So in terms of all these results, the SPRM uses deep learning with CCI optimization and provide higher accuracy and efficiency performance. With basically, it's basically improved the sensitivity range from 79 to 93, and also improved the average F score average and F score emergency compared to the previous studies. And also we have compared both local and cloud-based model. Both models are providing effective results in terms of emergency alert or warning, or you can say normal classes as well. Local predictive model performs slightly better for hypotensive emergency because it will indicate or provide the result in terms of locally and also in the quick process, so that we can take actions immediately. Similarly, cloud platform modeling, which shows higher accuracies for hypotensive and normative cases, where we have various, despite we have various imbalanced data set, the average F score across all classified exceeds over 90%. Moving ahead to the health card, second proposed system, an example of smart health card system. Here various vital signs parameters have been there. In terms of that, The sample rate has been identified, minimize the rate here, and then CPU control data processing unit has been placed, and then lastly health services, whatever it is needed, it been taken care. Moving ahead, health guard framework, it works something like this, where we have data processing, devices which collect the data, then anomaly, if the anomaly is detected, will train and analyze the model, then analyze the test data, and the action management and model are been there, which is basically notify the supervisor or anyone to take the necessary action. So in this basically we will get various effectiveness and feasibility of health guard system in terms of 4 questions. The 4 questions are: what is the performance of the health guard in different incident occurring on disease affective user and normal user. With that second question, what is the performance of health guard indicating or detecting different malicious attack, the 3 attack which I have earlier said. Similarly, what is the impact of number of devices? If we increase the number of devices, what is the performance of this health guard? And lastly, what is the impact of number of attacks occurs in HCR in terms of performance of health guards? So the devices and platforms considered for monitoring health guard are these, where blood pressures and heart rate, oxygen, blood oxygenation, blood glucose, then both human and movements and step sleeps, then blood hemoglobin, the models used, data sets used, and the values of features extractions have been considered. In this table, the device status in terms of different affected scenario has been considered, like what type of disease the devices have been there with respect to that: high caloric state, normal oxygen level, low blood sugar, extensive sweating, high blood pressures, all been taken care here. Similarly, once we have done the other activity parameters are also been considered in type of disease type, like stress, heart attack, sleeping, snore, or exercising, drunk, and walking. All other activity parameters have been also considered. Lastly, the performance of health guard is been detecting using non-malicious and malicious events, both with respect to recall, F1, precise, and accuracy. Then performance metrics in terms of increasing the device, like 8 device, 7 device, 6 device, 5 device, 4 device, that again have been taken care. Lastly, accuracy of health guard for different ML algorithms have been taken care. And then with that, the smart, we can say the smart health systems offer better diagnosis tool to treat patients, but they also arise in many security concern as discussed in the work. It also addresses the security concern in the research with respect to various health guard and machine learning based security in terms of any malicious attacks or activities are occur. Lastly, we evaluate this health guard in various multiple medicine setting, consider the healthy and diseases affected with respect to any SRH, and where we have found that the health guard can be achieved 91% of accuracy here. So these are the papers based on objective 3s being published. Conclusion. In conclusion, the proposed, we can say that the SPMR frameworks monitors remote patients with chronic diseases like blood pressure disorder or diabetes in real time. It also results showing the framework work equally well in identifying both identify multiple classes like emergency, alert, normal, or if the both cases there in local and cloud. Simultaneously, the studies uses deep learning method with unique optimization approach to reduce the error between the predictive and the actual value with CCE. And also additional, the framework use cloud-based prediction model which classify large amount of data and data, large amount of data effectively. Following are the features distinguished with respect to SPMRet for other frameworks. Robots, due to features and high performance, offline learning, which is come with LIP, local intelligence process. Expert can give context awareness, means recommendations based on the input of the data set, and they can decide what classes they need to choose, and use the deep learning algorithm, cognitive learning or techniques you can say, which is CE here to provide more efficiently. It's reduce the efforts of parallel processing, then develop local system. In contrast of if it's needed, it can identify patients critical state in locally without going the data into the cloud, and provide emergency, or you can say provide real-time assistance to the doctor if the data of the patient is looking like it is having critical problem. Then able to handle both unstructured and imbalanced data sets. And then non-users of sampling techniques, which has been again overfitting various other problem, feature execution, storage, monitoring, classification and predictions in terms of F1 score predictions, F1 score average, F1 score emergency has been taken care. Then lastly, high performance prediction accuracy, precise and categorical accuracy in terms of CCE have been taken care. With that, future scope. So in future scope, we found the future expensive and you can say improvement in terms of 3 points: extensions of other devices or diseases, performance evolutions, then cloud-based social networking services. So in extensions on other devices, we can use contact aware framework, will extend and testing with other data set such as cancer assistant or various cancers applicable wherever it is needed. Second, performance evolutions. The framework will need to undergo various kinds of testing to evaluate the quality of services, energy efficiency, and lastly, critical performance metrics in cloud computing environment. And last, in future work, we'll also explore the framework to deploy in cloud-based services where we can collaborate with multiple clinical or research institute to extend our work in real time with primary data sets. So these are all the references.
I have one basic question. We are talking about real-time monitoring systems. When we involve cloud and remote monitoring, both the things are creating delays.
Yes.
Cloud suitable for large data analysis, everything, and all machine learning available. But this additional delay is sometimes a problem for real-time monitoring system.
Understood.
Especially if your signals are categorized into critical. So what do you say about it?
So, sir, I'll say we are not basically 100%, you can say, considering all these factors, but for that we have introduced local intelligence process, where basically what we do before moving to the cloud, we initial whatever data has been extracted, we predict the data based on the we apply some algorithms in locally. It will be lightweighted algorithms, you can say, which is basically critical computations happen, and then the critical computation happen near the data source only, with basically with that it will reduce latency and increase, you can say, your whatever real time problem is been there. So it will identify the data in locally before moving to cloud. So we are processing that, we are applying that local intelligence process also here. In edge computing only, we are basically, you can say,
What was
deploying
the
our
highest
model.
accuracy in prediction?
Sorry, sir.
What was the highest accuracy in prediction?
Sir, in local, it is 92%, and in cloud, it is 96%. Sorry, sir. Sorry, my bad. In cloud, in local, it is 96%. In cloud, it is 92%. Sorry, my bad.
So when we deal with medical problems,
Yes,
even
sir.
this 4% back is also important.
Yes, sir.
Okay?
Yes, sir. Sir,
I'll
that
take
is
some questions by evaluator. Two evaluators were there.
sure, sir. For that reason only, sir, we are focusing on basically
The parameters, the vital sign parameters you have taken. Okay.
Yes, sir.
Are these parameters enough for evaluating a patient's health conditions, or would you propose additional indicators in future?
Yes, sir. So for that, basically, I have taken approval from doctor. It is here that these parameters is basically enough for identify any critical. नहीं वो उसमें नहीं
ये तो आपके पीपीटी में था, ये कहाँ से सर्टिफिकेट दिया आपने कहाँ से?
Yes, sir. That these parameters are enough.
This is for particular type of patient. Okay, for disease specific parameters will change.
Yes, yes, sir. So initially, this parameter is sufficed for chronic diseases, so that have been taken.
To what extent does the novel CCE optimization algorithm improve training, convergence and classification accuracy in the proposed DL methods compared to standard optimization methods like SGD or ADAN?
Sir, basically, I'll answer something like this. This categorical cross antagonomy, it's help to categorize various output. Okay, like we will basically classify our patient status in 4 ways, like normal, alert, warning, or critical situation. This cross antagonomy helps to identify the error between any predicted value or the actual value in terms of other related algorithms which are present. Again, in categorical cross antagonomy, we can basically readjust and go back propagation, readjust the weightage, and again provide those as an input to provide more accuracy or result, or more accurate result in terms of our outcome.
And in chapter 4, you have integrated LIP and CCE optimization techniques.
Both have been integrated.
So, what are the benefits?
So, sir, see, in locally, whatever will be processed as of now, we'll send those data to cloud for further data analysis, you can say, or visualization analysis also we can include here. So, in terms of cloud, wherever this data is being stored, whenever it is connected, I can say this data further analyzed, stored and integrated with various healthcare system to provide larger aspect of the project, you can say.
Is there any research done on analysis of false alarm or long-term monitoring periods in real life deployments?
So in terms of the literature review, there are long term which are being considered, like long term means the detections of presence, like it is being occurring, whatever data science or vital science has been taken there with respect to various patients, they have identified and they have studied them into the long time, and then they provide the input based on all this whatever data they have collected, like the patient is in any state or can be in future with respect to all these symptoms or all these parameters, can have some kind of disease in future. So that is been taken care of.
Then when we talk about security, usually we rely on detection of some problems only.
Sure.
In machine learning algorithm. We don't propose any method which will prevent this, okay, or make the things more secure. Like somewhere you mentioned blockchain will be maybe used for avoiding tampering and all. So something like that can be discussed here, but you just use some prediction methods or nothing.
Yes, yes, sir.
That's all I said.
Can you tell me one of the areas where you are in future planning to deploy this?
So, sir, we are, as I've told earlier, we are in progress to basically establish this system in cloud. Then multiple clinical or institutional will go and ask them to test into the real time. Then if in real time that whether we can identify any kind of means the system can be helped to the real environment, or that scenario will be we'll basically focusing on future work. And in real time, if I'll say now, it's currently it's something like that, like smart monitoring system, which basically predict like the glucose level of patients before taking any kind of like a wristband, you can say, like we can put it will basically provide the glucose level of patients in the day, and we can monitor it throughout the day, and after whenever we want, we can track that thing, what we are eating with respect to that, how our glucose level is being going up or down. We can track that thing. That also can be include here.
Would you be able to be include that blockchain like Sas mentioned, means
Sir,
future aspect also?
Yes, sir. So in terms of blockchains, as I mentioned, so blockchain is in terms of security, when we'll basically provide we'll talk about whole security. We'll go to passive attack also in terms of everything. Then we'll go for the blockchain. As of now, I'm not talking about in the research. It's not considered about all this. It's only considered about the external attacks. You can say whatever it is there.
And one more interesting comment from examiner was there. Include a brief personal reflection, 1 or 2 lines from the candidate about what was learned during the research journey. What did you learn? क्योंकि 2-3 चैप्टर में जा रहे हैं आज में. तो इस पूरी स्टडी में 1 or 2 lines.
So, sir, I'll go with basic. First is I've learned more about machine learning, deep learning, how machine learning helps deep learning to go in depth, and how deep learning form a base to the society, where basically you can say we can analyze, predict, provide accuracy of anything.
That is a technical thing. In smart healthcare system, suppose I say, what may be the future?
Yeah. So
you predict.
yes.
So technical से थोड़ा बाहर आके बात करते हैं, हो गया या
हो गया.
This is just like, other thing is very interesting and critical. Sir wants basically, what was your day? I mean, if you have been 1 minute of time and you have to explain the journey, how would you explain it?
Healthcare system के बारे में मैं.
Okay, sir. Sir, I try to basically, you can say, help people with my research to, you can say, provide assistance, or what I'll say, to overcome with whatever problem they are facing. Okay, and as I've mentioned also, with increasing population, the healthcare cost is also increasing. So this device, if it has been successful and it's been placed in market, I try to provide it as in free services, you can say. So
have you seen live somewhere that smart healthcare systems are being used somewhere?
So as I mentioned, wristband you can say, which cricketer generally used.
Simply recording the things. Yesterday itself I received a video of a very good physiotherapy center armed with robotics, and also suppose someone is having walking problem.
Yes.
Suppose this complete setup is done, is working, and each and every second parameter is being noted.
Noted.
And it's being analyzed, something like that. I have seen a center here in Delhi, this spinal institute is there, some spine injury related some. So there also I saw, they were not so smart, but I have seen many such machines which are smartly monitoring the patient's progress.
Yes.
All physiotherapy machines.
So likewise, sir, in cricket, basically I used to play. So there also sensor devices been putting into the bat of the batsman to check how accurate he is being hitting the shots. So that also is being there.
So with your permission, I'm speaking of lecture, formally we from Dr.
Amit Sundas.
Thank you all.
Congratulations.